Okay, folks, good afternoon. Today we're going to take a look at solving quadratics using something called the quadratic formula. Now, you should have done this in a previous class like Algebra 1, but I want to go through it again. First of all, what is the quadratic formula? Well, it's a method for solving any quadratic equation. I can use this every time if I wanted to solve a quadratic. Now keep in mind that the word quadratic means x squared, right? So I can always use this method. So why not use this method every time? Well, folks, it's more complicated than the other methods, and it takes longer. So if I can avoid using the quadratic formula, I will, okay? So I always want to go through the easiest to the hardest. Can I SAD map it? Can I factor it? Can I complete the square? And then if last case, then if I can't use any of those, but I still need to solve that quadratic, then I'm going to use the quadratic formula. Now, you probably have seen this before. The quadratic formula basically says this. If I'm given an equation, ax squared plus bx plus c equals 0, where a, b, and c, these are all going to be the numbers that are in the equation, correct? Well, I can solve for x using this equation right here. Now, this equation was actually created by completing the square, and if anybody would like to come to a tutorial and see how I can create this equation, then we can do that. But basically, given an equation where this side is where it's quadratic and you got 0 on one side, I can use the quadratic formula to solve it. And it basically says x equals negative b plus or minus square root of b squared minus 4ac all over 2a, where b is the number in front of x, a is your leading coefficient in front of x squared, and c is your constant. Okay? So that is the quadratic formula, and it's used to solve for x in a quadratic. Now, the thing that we have to be careful of, ladies and gentlemen, when we're solving quadratic equations, we have to be careful of the square root. You see, we have a problem with square roots. This part inside of here. There are only certain types of numbers that I know how to square root. Like, for example, if I have the square root of 16, I know the answer is 4. If I have the square root of 12, I know that's 2 square root of 3. I can do that. But if I have the square root of, say, negative 4, well, what number times itself equals negative 4? Well, that's impossible. There's no real number that would work, right? So the problem is, if this radicand, and the radicand is what's under the square root, if that radicand is negative, then we've got an issue. Now, the next thing, I always promised you that you would get 2 answers from your quadratics. Well, the 2 answers are actually going to come from the plus minus sign that you see in the equation. This plus minus sign right here, right there, there's going to be 2 answers. You're going to get negative b plus the square root of b squared minus 4ac all over 2a, and negative b minus the square root of b squared minus 4ac all over 2a. And those would be your 2 answers. Okay, so how do I actually do this? Well, the first thing we want to do is we want to focus in on what's under that square root. Because if I get a negative number in there and I'm looking for real answers, if I get a negative number, then I know that there aren't going to be any real answers. So let's take a look at this. Now, the discriminant. Folks, the discriminant is the b squared minus 4ac part. That's the part that's under the radical. Notice the discriminant does not have the radical. It's just what's inside. Now, since b squared minus 4ac is in the square root, we have to be careful about getting negative numbers, but we also have to be careful about getting a number of 0. Because if I square root 0, I know the answer is 0. And I'll talk more about that later. Now, here are the general rules about the discriminant. If b squared minus 4ac Suppose you get a positive number for him. Suppose this is equal to a positive number. Well, that must mean that you're going to get a positive square root, a positive number into the square root. That means you're going to get two real solutions because you're allowed to square root positive numbers. Now, suppose this is a negative number that you get for b squared minus 4ac. Well, that must mean you're square rooting a negative number. Well, because of that, you know there are going to be no real solutions because you can't square root negatives. And then lastly, what happens if b squared minus 4ac equals 0? Well, since the square root of 0 is 0, well, what that means is that you're going to get only one real solution. And we'll take a look at that later. All right, so I always tell students when they're doing the quadratic formula, always find the discriminant first, because you're going to have to do it anyways at some point, so why not do it first? If you find out that it's negative and you're only looking for real solutions, well, if you get a negative number inside the square root, you know the answer is no solution, and you don't have to go through all the extra work. So look at these examples that I've given you right here. These problems say, find the discriminant of each equation, then state how many real solutions the equation will have. Well, I know the discriminant is b squared minus 4ac. So b is 8, a is 3, and c is 12. Well, b squared would be 8 squared minus 4 times 3 times 12. So I get 64 minus 12 times 12, which would be 64 minus 144, which is negative 80. Oh, you see how that's negative? I know that if I plug this number into that square root in the quadratic formula, I can't square root negatives, so there's no real solutions there. Okay? So negative 80 is my discriminant. Negative 80 is my discriminant, and there are no real solutions. Now, looking at the next example, forgot my x. In this case, my discriminant, b squared minus 4ac, b would be negative 6, a would be 9, and c would be 1. Well, in this case, I would get negative 6 in parentheses squared. Don't forget, you gotta, whenever you plug a negative number in for a variable, you gotta put it in parentheses, times 4 times 9 times 1. So I get 36 minus 36 is 0. So my discriminant is 0. Well, for my rules up above, if I get a discriminant of 0, I know there's only one real solution. So this problem only has one real solution. And we're going to look at why later. Okay, and then lastly, on example C, my discriminant would be 9 squared minus 4 times 5 times 3, which would be 81 minus 60, which is 21. So in this case, my discriminant is 21. Since this is a positive number, well, if I square root of positive 21, I know that's okay. So this will have two real solutions. Okay? Now, in this last case, if it has two real solutions, then I know that I should go ahead and I can keep on solving, and then I'm going to plug that number into the quadratic formula. Now let's take a look at how we can use the quadratic formula and the discriminant to actually get the answers for x. So looking at the same three problems that we just did, suppose instead of saying find the discriminant, suppose it said solve each equation. Well, I still need to find the discriminant of each one, b squared minus 4ac. Well, again, we already did this. We got 64 minus 144 from the previous problem, is negative 80. Well, again, since that's what's inside the square root, I know there's no real solution here, and I don't have to actually plug in that number into the quadratic formula. Okay, so the answer is just going to be no real solution. Now, for the second one, when I did b squared minus 4ac, I got 36 minus 36 from the previous problem, which was 0. Now, because my discriminant is 0, watch what happens when I fill this in. I will get x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Well, plugging in my numbers, I get x equals, well, b is negative 6, so negative of negative 6 become a positive 6, plus or minus the square root of, well, the discriminant, we said, is the b squared minus 4ac, so that's the square root of 0, and that's all over 2 times 9. Well, folks, the square root of 0 is just 0. So this last part, does it make sense why this, if you have 0, what's 6 plus 0 or 6 minus 0? Doesn't that just disappear? So the only answer is just going to be whatever negative b is, which in this case is 6, over 18. And I do not know for the life of me why I wrote a 6 there. I apologize. So we get x equals 6 over 18, which is 1/3. And there's my single answer there, right? Okay, on the last one. On the last one, I'm going to solve this guy. Again, I would do the b squared minus 4ac, which we already got 81 minus 60, which was 21. Since he's positive, I know I have to keep working into the quadratic formula. I'm going to go x equals negative b, so b is 9, so negative 9, plus or minus the square root of 21. Again, that number would be the number you fill in there first. You always have to fill in the square root first, and that's going to be divided by 2 times a, which is 5. So we've got x equals negative 9 plus or minus the square root of 21 over 10. And that's how we solve an equation using the quadratic formula. Remember to check the discriminant first, because if you get a negative number, you don't actually have to do the quadratic formula. You can just say there's no real solution, be done. All right, we'll talk more in class.